Welcome to aroundBI. We are going to talk about junk dimension. What is junk dimension? Why do we create junk dimension? What is the use of junk dimension? We will walk through the topic with a simple example. Let's start with a retail transaction example. We are extracting transaction data and are trying to design our data warehouse structure. We have data on transaction date, product, store, order number, payment mode, store type, customer assistance, quantity and unit price. If we construct our schema for this information, date key, product key and store key will be stored in the fact table as foreign key that will be joined with respective dimension table. Order number. In previous video tutorial, we had discussed about degenerate dimensions and order number fits into that category. So as a degenerate dimension, order number will attach with the fact table. Quantity and unit price are numeric entities, so both will also fit in fact table. We will talk in detail about the remaining three fields. Payment mode. It tells what was method of payment, whether it was through cash or by credit or by check. We have three distinct values of payment mode. If we notice closely, we can say that the payment mode is always associated with the order number, because with each line number will have a payment mode. And the same case is with other two attributes. Next field is store type that tells the location of transaction, whether it was warehouse or marketplace. Again, it has only two values, warehouse and marketplace. We have third field that gives information if someone in the store has assisted or not. For lack of better term, we are calling it customer assistance, and possible values for that are yes and no. These three fields are of low cardinality. The low cardinality flags and indicators are quite common in transactional business. By low cardinality, we mean more duplicate elements in a column. So where will these three fields get a place? If we check all possibilities to store these three fields, one option is to ignore these and will not include into structure. But sometimes we need these indicators in reporting, for example grouping based on the payment mode or reporting based on store type. So it would not be a good idea to leave them. We can place these in fact tables, but these flags are sometimes unreadable with yes no value or sometimes as numbers 1, 2 or 3. And sometimes these indicators are text that are large in size that could significantly increase size of fact table. The increased size of the fact table could cause serious performance problems because of the reduced number of records per physical input output. So keeping them in fact table is not a favorable option. Other option is to make each flag and indicator into its own dimension. In that case, we need to add separate foreign keys to the fact table. But adding separate foreign keys to the fact table is acceptable if the resulting number of foreign key is still reasonable. An appropriate alternative approach for tackling these flags and indicators is to study them carefully and then pack them into one or more junk dimensions. A junk dimension is a collection of random transactional code flags and attributes that are unrelated to any particular dimension. By creating a junk dimension, we remove the flags from the fact table and place them into a useful dimensional framework. Generally in junk dimension, we keep Cartesian products of all the attributes possible values. So we have three fields here: payment mode, which has three possible values, cash, credit and check. Store type has two values, warehouse and marketplace. And customer assistance has two values, yes and no. So Cartesian product of these three fields will give an output of 3 into 2 into 2, 12 rows of unique combination. To join this dimension with the fact table would have a single small surrogate key for the junk dimension. We have to make sure that the size of junk dimension should not be too big. If a single junk dimension has 10 two-value indicators, there would be maximum of 2 to the power 10, 1024 rows. But if we have highly uncorrelated attributes that take more numerous values, it may not make sense to bring them together into a single junk dimension. For example, if we have 4 indicators that each take on 3 values, in that case, creating a single junk dimension is the best way for these attributes because the dimensions will have only 3 to the power 4, 81 possible rows. However, if the 4 uncorrelated indicators each have 100 possible values, we would suggest creating separate dimensions because there are now 10 million possible combinations. Moreover, in practical life, it is not a must to keep Cartesian products for all the attributes possible values, but should only contain the combination of values that actually occur in the source data or possibly can occur. So in this tutorial, we learned that a junk dimension is grouping of low cardinality flags and indicators, and it helps in avoiding messy design of the data warehouse. Creation of junk dimension provides an easy way to access the dimensions from a single point of entry and improves the performance of SQL queries. It also helps to keep the data warehouse design as simple and straightforward as possible, as that users will be able to access data easily. This is all about junk dimension. Please share your comments and feedback with us. Thanks for watching.